Good afternoon, everyone, and thank you for joining us for this live talk with STEM Ambassador Aditya from In Space Missions, which are world-class experts who design, build and operate physical and digital space missions for global customers from its UK site. It's great to see so many schools joining us today, and I was going to give a shout out to some of you, but for some reason I'm not seeing you on my screen at the moment, but no worries. Thank you for joining us. As part of our Summer of Space programme, Aditya will talk to you about satellites and the different roles in the space satellite industry. So please feel free to ask any questions by putting them into the chat, and Aditya will aim to answer as many as he can at the end of his talk. So you don't want to hear from me. I'm going to hand you over to Aditya. So good afternoon, Aditya.
Good afternoon, Lisa, and thank you for inviting me to do this. I'm very happy to be here, and I hope everyone who's listening to me on this call gets to learn a little bit more about what it takes to build a satellite and the kind of people who build them and operate them in space. So let me start first by telling you a little bit about me. There are 4 things I want to tell you. One is that I am a software engineer, which means I write code, and my code can be found on things like Boeing aeroplanes. I'm also a cricket player. I play cricket on Saturdays in the summer. I love dogs. I don't have a dog of my own right now, but I do love them a lot. And most importantly, I am a software engineer who works at a company called In Space Missions. And we are a company that builds satellites, and then we give them to somebody who launches them. And once they're in space, we operate the satellites. Now, first, what is a satellite? Some of you might already know this, but I want to go over it again anyway. So satellite is a machine that we build that operates in space, which means it operates far away from the Earth. Sometimes it goes around the Earth, sometimes it goes to other planets, and it can do many different things for us. Satellites can be very big, the size of buildings, like the James Webb Telescope, or they can be tiny and they can fit in the size of a hand, in the palm of a hand, and they carry computers and they carry radios on them. So how do they get to space? Satellites get to space by being launched from the top of rockets that take them all the way up into orbit, which means they fly 50 to 3,000 times higher than planes. Some of them go around the Earth once every hour. Some of them stay right on top of us all the time, so that it looks like they're not moving at all, but actually they're going around the Earth at the same speed as we are going round and round. Satellites can be tiny, as small as cereal boxes, or as large as buses, and they need something to run, so they use batteries and they use solar power to provide them electricity so that everything on the satellite can run. The satellite can also carry cameras and radios so that they can do the mission that they're supposed to do. But why do we need satellites? A satellite can be used to do many different things. You can use it to look at the Earth. Suppose you want to know what the weather is going to be like, so you can keep an eye on the clouds and you can keep an eye on the rains, so that farmers know when it is going to rain and when they need to water their fields and when they don't need to water their fields. You can use the cameras to look out into space so that you can look at galaxies and stars in the sky. But you can also use satellites to know exactly where you are on the Earth. And then you can use maps on your phone or maps in your car to navigate to wherever you want to go. So you have heard of sat-nav devices that fit inside the car, or you can find apps on your phone that do that. But apart from you can also use them to track wildlife. So in case there are endangered species like lions or giraffes or rhinos, then you can fit them with GPS collars and radio antennas, and then you can track where these herds of wildlife are going so that they can be kept safe. And beyond that, suppose you get caught in the middle of nowhere where your mobile phone doesn't work, then you can use a satellite phone to make emergency calls so that people can come and save you. So how does a satellite do all of these things? What actually fits inside and outside on the satellite to help you uh, do what you want a satellite do what you want a satellite to do? So first of all, satellites have computers in them. Now these computers are not like laptops. They're smaller, a little like the Raspberry Pis that you might find inside your house, inside your schools. And they are the size of your palm, and they are very powerful, but they take very little electricity to work. Satellites also have batteries inside them, batteries that can be found just inside your phone or your laptop. Their batteries are very similar in satellites, but sometimes a battery can get discharged. So to charge them, you need solar panels. So as every satellite will have some solar panels that will collect electricity from the sun and then use it to charge the batteries. Satellites also have radios on them so that you can connect the satellite and then make it work. And then you can download any data that's on the satellite. Then you need the body of the satellite. Somebody has to make the body that will hold all of these things. So we call it the structure of the satellite. And the structure is always made of metal so that it can be strong and sturdy. And then satellites will carry things like cameras. We call them payloads that will help them do the mission that they need to do. When you put all of these things together, you get a satellite that looks something like this. Now, this is just one of the models that my company makes. And you can see on this satellite model, you can see the cameras on the top with the gold leaf on it. You can see the solar panels on the side, and there are many antennas on it for all the radios that are fitting inside the satellite. So now if you want to make satellites like that, what do you need to study? The main things you need to study in order to be able to design a satellite is maths and science. We use a lot of maths and especially a lot of physics in sciences to be able to design them. So these are very useful things to study as you're going through school. But apart from that, it is nice to have a passion in things like astronomy, which is the study of space and stars and the sky. And also, if you understand how to use computers and how to write code for computers, there are lots of chances to work in the satellite industry. So let me introduce you to some of the people who I work alongside who help design and build these satellites. This is Bob. Bob is an electronics engineer. He builds the circuits and he tests them to make sure that they work. These circuits will connect the computers and the cameras and the solar panels and the batteries together. These two are Tom in the front and Joe behind him, and they are what we call systems engineers. They make sure that everything on the satellite can fit together and that the satellite will then do the work that it is supposed to do. This is Alice. Alice is what we call a mechanical or a structural engineer. She designs the body of the satellite and that she makes sure that everything can fit inside it and that it is strong enough so that when the rocket shakes it while launching, it doesn't break and it doesn't break anything inside the satellite. This is Alex. He is a software engineer. He writes the code that makes the computers on the satellite do what they need to keep the satellite stable and to allow it to take photos or allow it to send radio signals to the ground so that we can collect the data from it. This is Alice O. She's a technician and she makes all the connectors and all the wires that connect all the different boards to each other. And she also makes sure she can make sure the chips that sit on the circuit boards stay on by what we call soldering, which is a way to join computer chips to circuit boards. This is Lewis. He is one of the most important people at my company. Lewis is an integration engineer. Integration is when you take everything that is supposed to go on a satellite and put it together. And Lewis does this very, very important job of putting everything together so that the satellite finally looks like how you can see it in the photo. And also he tests it so that we know that the satellite will work when it gets very hot in the sun or very cold when it is in the shade behind the earth. So assembly and testing is the most important job in the space industry, and Lewis is responsible for this kind of work. And so there are a lot of engineers. You can see Mohammed, Richard, Anton, and Harrison in this photo. They do things like they operate the spacecraft, so they send it commands and they download the data. They work on quality and they work on systems. They work on how to manage the temperature of the satellite. So to get a satellite working together as one, it's a team effort. Not one single person can't do it by themselves. So it is very much something that people have to come together to do. But do you have to be an engineer to work in the space industry? No, you don't. You can start as an apprentice. You can also study just computer coding and then join us as a computer programmer. You can be a technician like Alice, who builds the connectors, and all you have to do is know how to connect things together, and you have to know a little bit about electronics. Or you can work in non-technical roles. You can work in finance and marketing. If you study business, then you can work on the business side of the company. You can be what we call project managers, who know everything that is going on, and then how much everything costs and how the project is going and how to manage the project. You can be a people manager who helps everybody do what they need to do and who keeps everybody happy at work. So, as you can see, the number of people who work and the kind of work that happens in the satellite industry is quite wide. And so it takes a really large team working together to build a satellite. So to finish, let me show you what the end product looks like and what it looks like when a team builds satellites so that they can be launched on top of a rocket. These are some of my colleagues. You can see them in the photo with 2 thumbs up because we have successfully made 2 satellites. And you can find all sorts of people in this team. Theo and Hannah are satellite operators, which means they can talk to the satellite and then they can give it commands. You have Andrea and Nick, who are in finance. So they are not science and maths people, but their work is really important in keeping the company running. You have other engineers, other technicians like Brett, who works along with Alice to help build the satellite together along with Lewis. And all of these colleagues of mine work together really hard to build something that is very cool so that you can have satellites that can do very awesome things from space. Thank you.
Thanks, Aditya. That was really interesting, and we are sure that our audience enjoyed your talk. So I'm going to hand you over to my colleague Sophie, who's going to put some of those questions to you.
Lisa, that's great. Okay, so so the first question that has come through is, what's your favourite part of your job?
The favorite part of the job, and I don't do it myself, but I love to watch it, is assembly. Because then what are individual things that are on people's desks and in the lab, the assembly technicians like Lewis and Alice start putting them together so that it starts to look like a final satellite. I love that part because then you can see it come together.
Fantastic. Okay, so I have a question here from Year 5 Doll class at Audley Primary School. They want to know, how much does a satellite cost to make?
So satellites can cost a lot of different, it's a wide range of money that it can cost. Now, small satellites can cost just a few £100,000. The ones that are the size of your palm or the size of cereal boxes. Large satellites can cost millions of pounds. And then there are the very, very large satellites like the James Webb Telescope that can cost hundreds of millions, if not billions of pounds. So it depends on how small they are and how long they're supposed to last. If they're supposed to last for many, many years, then they get very, very expensive.
Wow, that's a lot. So I've got a couple of questions here, very similar, from Oxbridge Lane School Year 5 and also again Already Primary School. How long does it take to make a satellite?
Yes, so a satellite can take as little as 12 months to make. If you've made a satellite before, and all you need to do is buy things and put them together again and test them before you fly. If you want to make it from scratch, it can take about 3 years or 5 years to make it. If you're building a very large satellite, something like, again, a telescope that has to observe the stars for a decade, then it can take as many as 10 to 15 years to build it.
Wow, that's a really long time. Probably longer than some of the people who are watching has been on this earth. A really long time. Okay, so Sycamore class is asking, how many years of experience do you need to be part of a team like yours?
And the answer is any number of years. We take people who are straight out of college and straight out of university. We take people who have been in the industry for 30 years. We take people who have been not in the space industry for 10 or 20 years, but want to work in the space industry. We're more than happy to take them on. So you don't have to have any experience and you don't even have to have studied space engineering, because we will teach you the space side of things as long as you come to us wanting to learn new things and wanting to learn about space. We will happily train you with that.
Okay, great. We've got loads of questions coming through now. So Cobham Free School, so that's year 5. What material are satellites made from?
Most commonly aluminium. Aluminium is a very good material to make satellites from because it is both strong and it is light. So this is the most common material that you'll see a satellite made out of. Some satellites use a little bit of steel because it's stronger, and some use titanium because it is light and strong, but it's expensive.
Yes, I can imagine. Okay, so Wallet Primary School is asking, how big is the largest satellite?
The largest satellites are generally the size of buildings, more commonly the size of buses, and now these days the size of say washing machines or dishwashers. But the largest satellites are massive. They're the size of houses or buildings.
Wow, that's a huge. That must be quite complicated to get them up into space.
Yes, those satellites take a long time to get up there, and they are very expensive to make. But they do a very important job of mobile communications and television channels and things like that.
Fantastic. Okay, so Lidget Green Primary School, 5S, asking, why do you enjoy working at InSpace?
Because I'm surrounded by a lot of people with a lot of knowledge. So I learn something new almost every day from them. And these are people who are very happy to share their knowledge with me. So every time I've asked a question, somebody's always made time to answer it for me. Before this job, I did not work in the space industry, so I had a lot to learn. And my colleagues have taught me a lot over the last couple of years that I've worked with them. So which is why I love to work at InSpace.
Fantastic. Okay, so Camelsdale School have asked, how many satellites have you built altogether?
Okay, so my company has built so far 4 satellites and currently is working on 4 more. and I'm personally involved with them, yes.
Rose Acres Primary School, Year 5, are asking, do you make rockets as well as satellites?
No, unfortunately, we don't make rockets. We work with companies that make rockets so that our satellites can fit inside them, but we don't make rockets ourselves.
Okay. Oh, so Windsor Clive School, Year 5, ask, how much does a satellite weigh?
Ah, a great question. Thank you for asking that. Satellites can weigh as little as 1 kilo or 2 kilos, and they can weigh as many as thousands of kilos. The ones we build are either 8 kilos or they're 100 kilos.
That's a lot. That's a lot of kilos.
Yeah.
Okay. So Cranbrook, 5 Red, School 5 Red. What would happen if there were no satellites in space?
It would be it would create a lot of problems for all of us. First of all, we would not be able to predict the weather very well, and which means that would affect how we grow our food, and that would cause one of the biggest problems for us. Secondly, it would mean your sat navs would not work, which means if you wanted to get from one place to the other, you would have to take out maps and keep them on your lap when you're driving by car, and that would be very difficult to go from one place to the other. Your mobile phones may not work, and your televisions may not work. And the most unfortunate of all would be that without satellites, we would get a less clear view of space, and which would mean we would not be able to do astronomy as effectively, and which means we would learn less about the universe without satellites that are in space and looking outside at the universe.
Yeah, that's a really good reason to have satellites, because it's such an interesting subject and thing to look at, spaces. So I've got a question here from St Joseph's Year 5. How long does an apprenticeship take?
That's actually, I don't know the answer to this one because I didn't get in through an apprenticeship, and I did not study in this country, so I'm not as aware of the system. So this is a question you might want to ask your teachers, and hopefully they will be able to help you find the answers to if you wanted to get in through an apprenticeship, what do you need to do to get there?
Okay. So yes, certainly we can have a little Google and have a little look to see what that might be. I've got a question here. What is the smallest satellite that have been sent into space?
So the smallest satellites that have been sent into space are called CubeSats, and they are 10 centimeters by 10 centimeters by 10 centimeters. So you might want to ask your teachers to help you look up photos of cube satellites, because they are very cute, tiny satellites that you can build models of yourself in class, and you can see what they can look like before they're launched into space.
The cube satellites, fantastic. Okay, I've got a question from Oak Class Ingham Primary School. Where do you take your satellites? Where are they launched?
They're launched from many places. So the most popular one is in Florida, which a company called SpaceX. You might have heard of it, and you might have heard of its owner, Elon Musk, because they launch rockets and satellites very often. There are a couple of now launch sites being started up in the UK itself, in Cornwall and in Scotland. And there are some around the world in South America, in Guyana, in India, and also in Russia and Japan.
So lots of different launch sites all around the world, and hopefully in the UK as well. So that's really good. Okay. So Year 6 Goma Junior School want to know what it looks like when a rocket takes off with a satellite.
There are many videos that your teachers can help you find to make you to let you see what it looks like when a rocket is launched, and also if there are videos that you can find which show how a satellite is released from the rocket once it reaches space. So they are very cool videos that are worth looking up.
That does sound like definitely something to look up. Okay, so I have here we go. So St Mary's Roman Catholic School, I think that is. What did you study at university and where did you attend?
So I have 2 degrees. My bachelor's degree was in India. So I studied at the University of Mumbai in Western India. That was many, many years ago. And then I came to this country and I did a master's in aerospace engineering at a university called Cranfield near Milton Keynes. Out there, I studied more about aircraft and not space. So that's my background, and I am very lucky to now work in the space industry, which is something that always fascinated me from when I was small.
Great. Okay, thank you, Aditya. So I have got a question from Woodland View Primary School, and they want to know, what data do you collect from the satellites?
Oh, great question, actually. One that I've never been asked before. We collect a lot of data from satellites. Sometimes it's as simple as photos, because cameras will take digital photos on the satellite. But then we need to see them on the Earth. So they will convert these to radio waves and they will transmit these to the ground. And then we will collect that data. And then we can show the photos to whoever wants to see them. But the other radio that we can collect, other data that we can collect is radio signals, especially if somebody is, for example, they're stranded in the middle of the sea. That's the kind of data we'll download. We will download exactly where they are so that we can inform the emergency rescue crews to go and rescue the people who are stranded in the middle of the sea.
Okay, so really important data. I've got a question here from Woodhamley School Year 5. How many satellites do you make in a year?
It actually depends on how many we are asked to make. At the moment, we are making 4 at the same time, but they are at different stages. So one of them is already being built. The other 3, we're still collecting all the information we need to build them. So about how high they need to operate, what kind of photos they need to take, how often the photos can be downloaded, things like that. We are still trying to answer those questions before we start the design. So we call this stage collecting the specifications of the satellite.
Okay, I've got a question from St James's School. Could a satellite be hit by a meteorite?
Yes, it can, and it happens. That is a very unfortunate thing, which we can't really protect against easily. So a satellite can be hit by meteors and it can damage satellites. And it has happened in the past that satellites have stopped working because they've been hit by a meteor. Now, if the meteor is large enough to be spotted by telescopes and by radar beforehand, then you can move the satellite out of the way so that the satellite is not hit. But if they are very small pieces of meteorite, unfortunately, satellites do get hit sometimes. It's rare, but it happens.
Okay. So I've got a question from Skelton Primary School. I think that's class Purple 2. What happens to the satellites once they've done their tasks?
A very good question. And there are very strict rules about this. Now, if your satellite is near to the Earth and it's finished its task, then you're supposed to move it down and let it burn up in the atmosphere so that it does not stay up in space. And you're supposed to build it in such a way that it will burn up while it's trying to come down so that it doesn't land on the earth and doesn't hurt anybody. If your satellite is too far away, then once it is finished working, you're supposed to push it out into deep space, and so that it flies away from the earth and again does not come in the way of anything else.
Okay, that's good to know, definitely. Okay, I've got a question from Year 3 Battyford Primary School. What inspired you to build satellites?
I will tell you what inspired me to work in space industry, and building satellites is just one way to work in the space industry. You can also do astronomy and things like that. The reason I'm interested in space is actually thanks to my grandfather, who used to take me to the roof to show me different constellations in the night sky. And when meteors or comets would appear, he would take me there, especially with binoculars, so that I could see the comet myself with my own eyes. And that kind of gave me a love for space, which is there still till today.
Oh, that's lovely. It's a really lovely story. I'm sure some of our students today are being inspired by looking into space, and hopefully by this talk as well. Okay, so I've got a question here from Ledbury Primary School asking, when was the first satellite made?
The first satellite was made in the 1950s, so about 70 years ago, by a country called the USSR, which is now Russia. And the satellite was called Sputnik. It was a small ball-shaped satellite, and all it did was go around the Earth and send out radio beeps just to know that it was there. Because we did not know before that whether we could send satellites, whether they could survive in space. So it was a very simple satellite, but it was a very important step for all of us.
Okay, I've got a question from Aldwoodley School. Why do you put solar panels on satellites?
Because because satellites need electricity to work. Now, electricity can be provided by batteries, but batteries can have only this much charge. It's a very limited amount of charge. So we put solar panels so that when the satellite is in sunlight, it can collect the electricity from the sun and use it to power the instruments and to charge the batteries. So solar panels are very important for a satellite to operate.
Okay, definitely very important. Right, let me see, I've got so many questions coming through. So Ravensworth C of E Primary School, Key Stage 2, how many different satellites do you make?
We make essentially two different kinds of satellites. We make small cereal box sized ones that weigh about 8 to 10 kilos, and we make larger washing machine sized satellites like the one I showed earlier in the photo in my slides, which is about 100 kilos.
Okay, and Class 5 from St Mary's East Grinstead, what's the most common use for a satellite?
The most common use of satellites is for communications, so either for radio or for television. So if you want to send messages or TV channels, for example, from one side of the world to the other side of the world, the fastest way to get there is through a satellite in space, because the information will travel at the speed of light.
Okay, so I've got a question here from Flamingo class. They are asking how many satellites are in orbit right now.
That is a question that I don't know the answer to, actually, but it is possible that you can find it by asking your teachers to help you search for the right answer. Okay,
so that's definitely a little exercise for after the talk's finished. I think so.
And I would love to know the answer too, actually.
Fantastic. So, yeah, so if teachers want to email through to the STEM Hub, we'll put the email address in the chat, and we'd love to hear what your findings all are. Okay, so let me see. Oh, so many come through. Excuse me. Leighton Primary, Blackpool. What is the hardest part of building a satellite?
Oh, the hardest part of building a satellite is not knowing till very late on if the satellite is going to survive harsh conditions, because you can design everything on a design the satellite on a computer as much as you want, but till you actually take it to somewhere where to a test facility that can, you know, make it put it in an environment where it gets as hot as it would get in space, or as cold, or in vacuum, or the shaking of it. You don't know how it is going to do. And then you don't want to find out too late that a satellite will break the moment a rocket shakes it. And so that is the toughest part of it. So you have to design it very well, and you have to analyze it very carefully to make sure that once it is built, it can survive under very tough conditions.
That does, yeah, that sounds very difficult. I can imagine it would shake a lot when it was going up in space in the rocket. Okay, let's see. I think we've still got time for a few more questions.
Sure.
So lots of quite similar questions, but really good questions. So Sycamore School, what kind of missions do your satellites do, and what is the next mission?
The kind of missions that my company works on is things like monitoring how much forests have changed to see the impact of climate change on forest coverage. We've worked on we've worked with customers who want to detect if a ship has broken down in the sea and to find its location. We have actually put wildlife tracking antennas on our satellite that can receive signals from herds in the middle of forests and deserts, things like that. And one of the things that we are hoping for is actually to get a mission where we can look at stars to see how the what the ultraviolet light is like coming from different stars in the universe. So it is something we are hoping to build in the future.
Okay, so yeah, lots of really important things that they really definitely, certainly anything to do with our climate is very, very important. So I've got a question here from 5G at Park Lane Primary. What happens to the rocket that has taken the satellite to space?
So there are two things that can happen. One is that especially Elon Musk's SpaceX is very good at this. The parts of the rocket that launch it actually come back to the Earth, land, and then they are reused. Sometimes the parts of the rocket are designed so that they just burn up while coming back down so that they can't be used again. Or if you are launching a satellite very far away in space, then the body of the satellite is the body of the rocket actually is moved away and sent far away from the Earth so that it doesn't stay near the satellites and it doesn't damage any other satellites in the same area.
Okay, I've got a question from Marcus Rashford class at Brampton Primary. They want to know how high the satellites orbit.
So the satellites can orbit from as near, and by near I mean they're still much further away than aeroplanes fly. They can be about 300, 400 or 500 kilometers from the ground, or they can be as far as 60,000 kilometers from the ground if they are orbiting around the Earth. Now, of course, we have sent spacecraft to Jupiter and Saturn and Pluto, and those are a different story. But the ones that orbit around the Earth can be anywhere between 300 and 60,000 kilometers away from the surface of the ground of the Earth.
That's a very long way away. Okay, so Year 5, West Newcastle, they're asking, what happens when a satellite breaks?
Ah, yes. So, unfortunately, when a satellite breaks, the parts can stay just there. Now, if we are lucky, the parts will come back down to the Earth and they will burn up, and then they will not cause a problem to anything else. But if a satellite breaks up and the parts stay where the satellite is supposed to be, then the problem is what we call space debris. And these parts can unfortunately damage other satellites. So we have to be very careful. So what people in the space industry do is they keep track of where all of these little pieces are. And if they are going to hit any other satellite, they inform the owners of those satellites so that they can move them out of the way. Now, the other thing that the space industry is doing is they are trying to find ways that they can remove such debris from space so that it doesn't cause problems to satellites in the future. Now, there are many different companies working on this problem, and they're thinking of different ways to do it. They will either use nets to remove such parts, or they're thinking of using lasers so that they can burn up these parts before they damage other satellites. But it is a problem that needs to be solved very soon.
Yeah, that is interesting. We have actually got a talk coming up just on that subject, and we will be sending out details of future space talks for primary, so look out for those. Right, we have got time for a couple more. If you can still go strong there, Aditya. Okay, so here we go. Rosewood Academy, would you like to go into space?
Yes, absolutely. I don't think I will get a chance to go in the near future, but hopefully someday I would really love to go there.
Fantastic. I'm sure lots of us would love to do that as well. Year 5 Carbon Free School. What is the most fascinating discovery you have made about space using satellites?
Oh, that's a tough question. I think for me, the most fascinating one was how many different things can be done using just a small satellite the size of a cereal box. The ones we have built can do 8 different things, or I mean, as in they carry 8 different antennas or cameras, and we can use them for a lot of different types of missions. And I didn't realize you could do all of that in such a very small shape. And the other amazing thing in the recent years has been how often rockets launch, because I never really paid attention to it, but now satellites are launched once every couple of weeks, and there is a lot of activity going on in the space industry around building and launching satellites.
Okay, so I've got a question here from Year 5, Barley Close School. Do you have a favourite satellite?
Oh, yes, and the answer is the Hubble telescope, which has now been up there in space for about, I think it's 30 years. I'm not totally sure, maybe 25 years. The Hubble telescope is the first really large telescope we put into space, and it has given us some of the most stunning views of the universe. And because of that, it is my favorite satellite.
Okay, right, I think we've got time for just one more question. So I'm just having a little look to have to see who would, what our final question is going to be. got some really great questions here. Lots of people thinking in very similar ways. Oh, here we go. So Henry Moore Primary School, Class 5C. Has a satellite ever gone missing?
Yes, they do go missing. Sometimes they just stop working, and because they stop talking to you, you have no idea where they are. And then your only hope is that either it restarts by itself, or you use companies that have very big radars that can track satellites in space, and then hopefully try to find them using these big radar antennas to see where they are, and hopefully then try to send it commands to start back again. But yes, it has happened more than once that satellites have just stopped talking to you and then you don't know where they are.
Oh, that's a shame. Okay, well, thank you everybody who's put questions in the chat. Really, so much enthusiasm and some really great questions there. And thank you so much for answering them, Aditya. I'm just going to pass over to my colleague Lisa, who's just going to finish up for us. Thank you.
Thanks again, Aditya. As Sophie said, that was just such an informative and engaging talk. I hope you don't mind. I pulled out one question which Sophie didn't get around to. Sure. And we have still got around 70 schools still with us. So I wonder if you could answer this question. It came from Porter's Grange Primary. Potentially, what could a satellite do in the future that it can't do now?
Oh, that is. So there are some very a couple of things I think. There are some very interesting developments happening in trying to do artificial intelligence on satellites. So to make satellites smarter, so that, for example, then you could predict weather far better, because then the analysis could be done on the satellites and you could know instantly what's going on. What else could you do?
Maybe they're doing everything they can. That's all we know. What do we know about the future? It's space.
Yes, it might be, and it's a good question that I'm not sure if I can answer more than what I already have.
No, but thank you very much. As we mentioned, there are just so many questions. So we thank every teacher, every student for joining us today. And we're sure that they will be inspired to learn more about careers within the satellite industry. It just sounds so amazing. So thank you very much, everyone, and have a lovely weekend. Goodbye, everyone.
Thank you so much. Goodbye.